Hello everyone, welcome back to another video. So today we will discuss solutions to weekly contest 390, and I was able to solve all four problems, but I will not discuss this question. So I will not explain brief solution about this question because I am also unaware of that topic. So I will just give you an idea how to solve it, and you can learn that topic and try to understand the solution. So let's move to first question. So in first question we are given a string and we have to return maximum length of substring such that it contains at most two occurrences of each character. So there should be no character which contains more than two occurrences. For example, let's see the first test case where we are given a string BCBBB and CBA. So here the substring of length 4 which is starting at index 4 and ending at index 7. This substring only contains all the occurrence of all the characters in this substring is less than equal to 2. So here answer is 4. If we check all the substrings, there is no other possible way. And similarly in second test case, the string is an identity string. So each character is same. And here the only possible substring maximum of length 2 is possible, which is maximum, and so answer here is 2. So as you always know that first question has less constant because we are expected to write a brute force solution. So first I have declared, let's see the code. So I have declared a n as dot length, and minimum answer will always be 1 because a string of length 1 is always uh, does always have minimum, all the characters are occurrence less than equal to 2. So minimum can be 2, but I took just 1 for base case. And then I'm iterating over all substrings and storing the frequency in a map, and whenever the frequency of any character becomes 3, I will take the answer as max of j minus I. So j minus I means the string that starts at j and ends at j minus 1. So that string length can be represented by j minus 1. Now if I don't find any string uh, ending at any position till n, that means I will come at this condition where j equal to n minus 1, and then I will take just answer equal to max of n minus I because I couldn't find any substring. I couldn't find any character whose occurrence was 3. So in the first case, if I start from fourth index, there will be no ending condition like this. So to handle that, I have to add another condition where j becomes n minus 1 and answer becomes here, I the length becomes n minus I, basically starting at ith position and ending at n minus 1 index, and finally just return the answer. So this was brute force solution. So let's just move on to second question. Now in second question what we are given is we are given a positive integer k, and initially we have an array uh, of length 1 and whose value is also 1. So we can perform any of the following operations any number of times. So two operations are, one by choose an element and increment it. So if I choose this one, I will increment it and the value will become 2. And second option is to duplicate an element and add it to end of array. So we have to return minimum number of operations required to make sum of elements of final array greater than equal to k. So we have an array at start. One of the operation can be just duplicate this one until there are k ones. So for example, if k was 11, I will just duplicate this one 10 times. So the sum becomes 11 and our answer is satisfied. Now the number of operations required for this case are 10 because I uh, duplicated one 10 times. So in general terms, here the number of operations are k minus 1. Now if I decide to make it 2 first and then duplicate it, so how many times I can duplicate, how many times is required? 2 to 4 to 6, 8, 10 and 12. So here required is 6. So first what I did was 2 minus 1 is number of incrementation operation, and 5 is duplication operation. Now for, let's say I take 3, so how many times do I need, how many times 3 is required? So first 4 times 3 is enough because sum becomes 12 and it is greater than equal to 11. Now the number of operations in this case will be 3 minus 1 plus 3, which is 5. Similarly for 4, we can say 4, 4 and 4. These 3 are enough. So number of operations 4 minus 1 plus 2. So 5. Now uh, first it is important to understand that doing incrementation operation first and then duplicating is always optimal, you can say optimal sequence of operations, because let's say 1 and I have to make this sum equal to 5. What can be possible way? I will just increment this uh, 2 to 3 and then duplicate it. So here I require 2 operations for making 1 into 3, and to duplicate it I required 1 operation. Now other way can be 1, then increment the 1 by 2, then again duplicate it, and then again you can say increment it. So if we are when we are duplicating a number, the sum increases by x. Let's say if we are duplicating a number x and the sum increases by x. Now if we are duplicating a number at when we are having a maximum number x minus 1, the sum increases by x minus 1 and then we increment it again, so this becomes x minus 1 x minus 1 x. But when we have a number x minus 1, we first increment it and then duplicate it, so sum of this sequence will always be greater than this, because here sum is 3x minus 1 and here is 3x minus 2. So you can extend this idea to any number of occurrences in the array, and we can prove that always this uh, first increment then duplicate sequence of operation is optimal. This is also kind of intuitive, you don't need to prove this, you will just understand if you think uh, or write some examples, you will understand this why. And for the solution, basically we have to check for all integers from 1 to k. So we came till 4 last operation can be 11 itself. We can just increment the 1 to 11. So here number of operations will come 11 minus 1 plus 0. Now we have to take minimum of all these operations. So we can check for all of these operations and find the answer. Now how to calculate this number of operations? Let's say I have to convert the first element to I and then duplicate the elements. So the incremental operations are obviously I minus 1. And now how many operations are required to make it greater than equal to k? So I have um, after incrementation I have an element I in my array. So I into x means if I duplicate this number x minus 1 times, I get sum as I into x. So this sum should be equal to k minus k. So x should be greater than equal to k by I. So for example, if uh, k here was 11 and I was 3 and k was 11, so I have to make 3 into 4. Basically 3 into 4 is greater than 11, greater than equal to 11. So 11 by 3 gives me 3 point something, but x is integer, so I have to take flow C log k by I, and that is our x, and the number of operations required to duplicate is x minus 1. So overall our formula becomes I minus 1 and x is floor value of k minus I, and we will just add x minus 1 into number of operations and take minimum of these operations to our whole answer. So let's just see the code. So if k is equal to 1, that is just base case. We have to just return 0. Now then I declared an answer variable for storing int max, our current max minimum answer, and I'm iterating over 1 to k, and the incremental operations is I minus 1 as we discussed, and the duplication operations are seal of k by I, and this is kind of a formula to take seal. We just add I minus 1 into k. So the range of division, if it is uh, if the k is divisible by perfectly divisible by I, then adding I minus 1 will not make any difference in the overall division. But if it is not, like it is giving a value in double like 3.1, 3.2, so this adding I minus 1 will make it above 4, and x minus 1 is the second type of operation, so I'm decrementing just d2, and finally taking answer with minimum of answer comma d plus d2. So this was second question. Now we will move to third question. So in third question we are given two vectors of size n, and in each ith step, if frequency of I is positive, nums of I are added into the collection, and if frequency of I is negative, nums of minus frequency of IDs of nums of I are removed. Now we have to return an answer such that answer of I represents the count of most frequent ID in the collection after processing the ith step, or we can say ith query, and we have to return that answer vector. And if the collection is 0, okay, so let's just say we first test this. 3, 2, 1 and 2, 2. So this is our ID array, and this is its frequency array. Now at the start we had only two arrays. So what we had is at the start, let's at ith step where we are at position I equal to 0. So I will process this first query. So I will add three elements of id 2 in my collection. So and for now I have three ids of three frequencies of id 2. So here answer is what we have to return. We have to return maximum count of most frequent id. So here count was 3. So uh, answer of 0 should be 3. Then at I equal to 1 I have 3 comma 2 as one of the ids. I am not removing anything and adding two ids of two frequencies of id 3. Still here the answer is 3 because my most frequent is most highest frequency is 3 still. Then I equal to 2. At I equal to 2 I am removing three frequencies of id 2. So this three frequencies will become 0 comma 2 and this will remain 2 comma 3. So here answer comes 2 because this is now highest frequency. Then I am adding 1 of 1. So at I equal to 3 I have 0 comma 2, 1 comma 1 and 2 comma 3. So here answer comes out to be 2 and our vector should look like 3322. Yes, so 3322. Similarly for 553 case the answer is 201. You can just read this for simulation of the solution. And how to do this? So after reading this question, first thought was set basically a self-balancing data structure such that we always get this maximum frequency, and I cannot use priority queue because I cannot erase any frequency directly. I just need to increment the current frequency or decrement while updating a certain frequency of id. I need to erase the previous frequency and add new frequency in it. So at in this case where I was 1 and I was processing I equal to 2 query. Basically what I did was erased 3 comma 2 which was older frequency and inserted 0 comma 2 which is a newer frequency, and in set we can just return last element because it will always be maximum. So in this way we can process each query. So what we have to use, we have to use a set of pair where first uh, first position is storing frequency and second position is storing id, and whenever there is increment or decrement we erase previous frequency and insert new frequency, and finally just print last element. And we also need a map to store current frequency of element. So for erasing the previous frequency we should know ID, and also we should know frequency of ID. Now for calculate find getting that frequency, we can use a map. So if we see code, you will better understand. So I declared a pair of long and also a map, set of pair and a map, and I declared a variable n and a vector for storing the answer. Now if I equal to 0, basically first ever query, that is just increment the b of I and insert frequency comma id, and here at first case answer would be just b of I because that's the only frequency. Now else if st dot find mp of I comma a of I not equal to st of dot end, so if I have such pair in set, I will erase it. I don't also need this condition, but I just wrote it for avoiding runtime issues. There will be, I think, always such case except when the first frequency itself is negative, but that is not the case here. But it is it is good to write this to avoid any runtime error. And whatever frequency current frequency was there, I will just add b of I. If it is negative, it will subtract. If it is positive, it will increase. And I will insert the new frequency comma id in the set, and the last element of set can be accessed like this, previous of st dot end, or you can also write minus minus st of end and this symbol and first, and I will just push it into D and just return answer. So this was third question. Again, uh, standard question if you have solved this type of questions. So let's just move on to fourth question. Now fourth question, I will not explain everything, but somewhat useful observations. So in this case we are given two vectors, and uh, we have to for each word string in second vector, we have to find the string in first vector such that it has longest common suffix with the words query of I string, and if there are more or two or more such strings, we have to share the longest common suffix, and if there are two or more strings, we have to find the string which is of smallest length, and if there are two or more of that smallest length also, we have to find that occurred earlier in words container. So there are a lot of conditions here, but that will be not a problem because the conditions are written to make the solution itself easier, because while writing solution you considering these conditions is kind of easy, and we have to just return this answer. So you can read this if you still don't understand. So key observation here is just reverse all the strings and we will have to match prefix. Matching suffix is difficult, but matching prefix is not. So for A, B, C, D, and let's say I have to match C, D. Now matching suffix is difficult, but if we just match the prefix, let's say, we basically have to find length. So we can just reverse both the strings and match prefix basically. So this was first condition, first answer. What we have to do, we have to match prefix of each reverse all the strings and match prefix of each string to any of the strings in words container. Now you can pre-compute all the prefix strings of words container and store it in map and find all the and again for words query reverse all the strings, iterate over all prefix strings, and for if there is a mapped value in original frequency map of all strings, just take that as answer and basically print the answer. So you can do this by just the same. What you can do, first reverse the strings, then calculate all the prefix strings DC, DCB and DCBA. Now if you just map this with an integer as index, for example here index was uh, 0, DC was also 0, DC 0, and this is also 0, and also another map is required to store the length of the string. Length of D here is 4, similarly length of DC 4, for this also 4, for this also 4. Now if I find D in further substring, like for example in DCD I reverse it, I found DCB, I can find this D again, but that time length of D, the length of string which is giving minimum, then which has minimum length and also giving D as prefix is 3. So I will update that index to 1 and I will update that length to 3. Similarly I can also find DC, so update this index to 1 and update this length to 3. DCB also 1 and this 3. I cannot find DCBA, so it will keep 0, 4. So this is basically what we have to do. But if you store all the strings, it will probably give you MLE, so memory limit exceeded. So there is some optimization which is called as string hashing. Basically we convert every string to an integer such that there is always a unique integer which represents a string. So there are various string hashing algorithms. You can just search string hashing on this website. So these are all the string hashing functions. So I just kind of learned this. I also don't know a lot about this. So what I did was I knew this logic where I'm just basically hashing. So this is the mathematical formula for it, and I can calculate this hash in O of n time. So I basically calculate this hash, and here if you read this, no collision probability. So there is a probability of collision if you use basically here we are using a mod 29 plus 9. Now for a string of length 10 raised to power 6, if you see constraint around are find to 10 raised to power 3. If you use mod as 10 raised to power 9 plus 9, it will have collision issues. So for the stress test, for here if we have a test of length, let's say 530, and this is basically stress test, maximum constraints available, there is high chance that there will be a collision. So two strings will give same integer input, same hashed value, so this is called as collision. So to avoid this collision, what we have to do, we have to just increment this mod, increase this mod. So what I did is I fine-tuned this mod to, I guess, 2016 plus 7, and just submitted it, and I got accepted. So thank you for watching.